Now let us see what is electromeric effect. Before that, we should know what is electron density. Now an orbital is a collection of points obtained by plotting a graph between probability and distance of the electron from the nucleus. So for example, in the case of a hydrogen atom, we have the 1s orbital and it will contain a very large number of points, and each point represents the probability of finding the electron. Now a better term used is electron probability density or electron density, which is the number of probability points in unit volume. Now it is a measure of the charge of the electron possessed by that orbital. Now consider the carbonyl group C double bond O and the structure 1, which is the most stable canonical structure, and the structure 2 is an unstable canonical structure. Now structure 2 is obtained by ionization of the pi bond or polarization of the pi bond, like this. Now here the 2 electrons in the pi bond goes entirely into the orbital of oxygen, giving it a negative charge, and carbon is left with a vacant orbital and a positive charge. Now the resonance hybrid will be having this structure, where carbon possesses a delta positive charge and oxygen possesses a delta negative charge. Now suppose the contribution of character of canonical structure 1 is 80% and the contribution of character of structure 2 is 20%, then the charge carried by carbon will be equal to 80 into 0 by 100, because in structure 1 the charge of carbon is 0. So 80 into 0 by 100 plus 20 into 1 by 100, because the carbon in structure 2 possesses positive 1 charge. So the sum will be equal to 20 by 100, that is 0.2. So delta here will be 0.2. And the charge over oxygen atom is similarly 80 into 0 by 100 plus 20 into minus 1 charge for oxygen, therefore 20 into 1 by 100. That will be equal to 20 by 100, that is 0.2. So delta negative will be equal to 0.2. And 0.2 negative charge means 0.2 electron. Since electron is a particle which cannot be divided, it is absurd, it is meaningless to say 0.2 negative charge. But we can introduce the term electron density here, and we can say that oxygen atom possesses a higher electron density. Now delta will be having a value between 0 and 1, excluding 0 and 1, so that delta is always a fraction. Now coming on to the mesomeric effect. Now consider a conjugated system, that is C double bond C, single bond C, double bond C connected to a group X. Now X can contain a lone pair, a positive or negative charge, or X can be equal to a double bonded system, A double bond B, or a triple bonded system, A triple bond B. Now this double bond and triple bond will be conjugated to the conjugated structure. Now in the first case we consider X containing a lone pair. Now C double bond C, single bond C, double bond C, and single bond X with a lone pair over X. Now initially we suppose that the pi electron between C4 and C3 ionizes or polarizes towards the carbon 4. That means the electron pair in this pi bond will be going entirely into the orbital of carbon 4, so that it gains the electron share of this carbon 3 and attains a negative charge and a pair of electrons. Now carbon 3 will be left with a vacant orbital, and the carbon 3 will possess a positive charge. Now simultaneously, the pi electron pair between C2 and C3 will move into the orbital of C2, and there C2 gets the share of this carbon, so that it gets a negative charge, an orbital containing a pair of electron and a negative charge. Now the positive carbon possesses a vacant orbital. Now this vacant orbital over positive carbon and the filled orbital over C negative, that is second carbon, will overlap. Now during that process, one electron is transferred to carbon 3 so that its charge neutralizes, and we get a pi bond between C3 and C2 as here. Now simultaneously, the electron pair over X shifts to a position in between C1 and X. Now before that, C1 is having an orbital which is having no electron and so a positive charge. When the lone pair orbital of X overlaps with the C1, which is positive and having a vacant orbital, one electron is given to C1, so the charge of C1 is neutralized, and since one electron is lost from the group X, it gets a positive charge. So all these processes occur simultaneously and can be shown by an arrow starting from the lone pair and ending in between C1 and X. Simultaneously, this pi bond will be shifting in this direction between C3 and C2, and simultaneously this pair of electron, that is pi electron pair, will shift over carbon 4, giving it a negative charge, and we get the canonical structure 2. So these two canonical structures are possible for the system, and structure 2 possesses a configuration like this. So in this structure, this configuration, the positive and negative charges are close to each other, so their fields will be just overlapping, and so there will be a tendency for the positive X and negative C to come closer, and during that attempt, this angle and this angle decreases, so X moves towards negative C and C moves towards positive X, and so naturally this bond will move in this direction, this bond will be moving in this direction, this angle will be decreased, and during this decrease in angle, this pair of electron and the pairs of electron here come closer, so that electron pair repulsion or bond pair repulsion will occur. Here also bond pair repulsion will occur, and so due to repulsion, the potential energy of the system is raised, making the structure unstable. Now at the same time, the bond between C3 and C2 will be stretched. Now bond is like a spring, so whenever a spring is stretched, there is strain, and the potential energy of the system increases, because when we release our hands, the spring will retain its original position. So the stretched condition is unstable, and an unstable condition will always possess a higher potential energy. Again, the structure is unstable. Again, the resonance will occur because there is a movement of electron pair along the carbon chain. So electron pair movement extends over the carbon chain and on the group X. So length of conjugation is increased, and as the length of conjugation increases, a higher potential energy is needed for this movement of electron pairs, and there is a lower potential energy for the resonance hybrids. So due to resonance, stability is attained. Now here X donates part of its electron density to the conjugated system, because X will be possessing a partial positive charge, and C4, carbon 4, will be possessing a partial negative charge. So electron density is flowing from X to the conjugated system. Now, whenever electron density is flowing from the group X to the conjugated system, we say electron density is injected into the conjugated carbon chain. Injection means you give something to the system. Here the group X donates its electron density to the system, conjugated system, and so electron density of the conjugated system is increased, and this effect by which a group attached to a conjugated system injects electron density into the conjugated system is called plus M plus mesomeric effect, or plus resonance effect, or plus R effect. Now an example for a group which shows plus M effect is the NH2 group. Now here NH2 group donates electron density to the system in a similar manner as shown in the previous case. So a lone pair of electron of nitrogen goes in between, say, C1 and NH2 group, and the bond between C1 and C2 migrates to the position in between C2 and C3, and simultaneously the pi electron pair of the bond between C4 and C3 moves entirely into the orbital of C4, giving it a negative charge and nitrogen a positive charge. Now the reverse movement also occurs. Now you start the arrow from the negative charge. It is enough to start the arrow from the negative charge to end between C4 and C3, and the bond between pi bond between C3 and C2 moves to a position in between C2 and C1, and the bonding pi bond electron between C1 and NH2 group moves entirely into the orbital of nitrogen. Now nitrogen carries a positive charge. Whenever a species carries a positive charge, that means there is a vacant orbital present. So almost in all cases where a species is possessing a positive charge, there will be presence of a vacant orbital into which electron pair may be received. So the nitrogen is getting neutralized by accepting pair of electron, and we get back this structure. So resonance between these two structures. And when we calculate the charge carried by nitrogen and carbon, since the second structure, that is the charged structure, is unstable due to this reasoning here, its contribution of character will be less, so that the extent of negative and positive charges over the atoms will be less than 1, and it will be a fraction, and we represent the resonance hybrid by such a structure where delta negative charge is carried by carbon 4 and delta positive charge is carried by nitrogen. Similar is the case with NOH group. So NH2 group donates electron density to the conjugated carbon chain, and we say NH2 group shows plus M effect or plus R effect. Now here we must note one thing, that nitrogen is more electronegative than carbon. The electronegativity of carbon is 2.5, and for nitrogen it is nearly 3.0. So nitrogen is more electronegative than carbon. Even then, the electron pair shift occurs from nitrogen, and this is due to the attainment of stabilization by movement of the electron pair along the carbon chain. So the length of movement is increased, a higher potential energy decrease is obtained, and so due to resonance we can say the stabilization occurs, and this causes the movement of electron pair from nitrogen. And coming to the case of an OH group connected to a conjugated carbon chain, there are also shift of electron pairs. One of the electron pairs of oxygen atom in OH group will be shifting like this. Simultaneously the bond shift occurs here, bond shift occurs over carbon 4, and so the oxygen atom of OH group possesses a positive charge in the unstable canonical structure, so that the resonance hybrid will possess a partial negative charge on carbon 4 and a partial positive charge on the oxygen atom. Now here also oxygen is more electronegative than carbon. The electronegativity of oxygen is 3.5. In spite of this high electronegativity, electron density flows into the ring, and this is because of attainment of stability due to resonance. Now here one thing we should remember, that is, in NH2 group there are 2 hydrogen atoms. In OH group there is 1 hydrogen atom. Now the bonding electron pair in the 2 hydrogen atoms connected to nitrogen will be slightly shifted towards nitrogen because the electronegativity of hydrogen is 2.1, so which is lower than the electronegativity of carbon and that of nitrogen. So NH bond we say is polar, and the polarity of NH bond, nitrogen atom carries a delta negative charge, and this delta negative charge will not be equal to the magnitude of this delta. So a slight negative charge over nitrogen can neutralize this positive charge to some extent. So a positive nitrogen can be stabilized by donating electron pair towards nitrogen in the NH bonds. Similarly, in the case of OH group, the bonding electron pair between O and H will be slightly shifted towards oxygen atom, partially neutralizing the delta positive here. So all these factors will stabilize the charged canonical structure. Now consider the case of halogens. Consider a fluorine atom connected to a conjugated system. Now due to resonance, the electron pair here moves in this direction. Simultaneous movement here and simultaneous movement here, giving carbon negative and fluorine positive. Now in the resonance hybrid, the end carbon atom, that is carbon 4 here, will possess a partial negative charge, and fluorine will get a partial positive charge. But fluorine, we know, is the most electronegative element. The electronegativity of fluorine is nearly 4. So it is the most electronegative element. And since in the case of NH2 and OH, the bonding electron pair between NH and OH may be shifted towards nitrogen and oxygen respectively, thereby neutralizing the partial positive charge. There is no hydrogen connected to fluorine in these structures. So since fluorine is most electronegative, it will be having a tendency to withdraw electron density from the conjugate system. So fluorine will withdraw electron density from the conjugated system, means the magnitude of delta negative will be less here. So chlorine being most electronegative shows an electron withdrawing character. Now this electron withdrawing character based on electronegativity is called inductive effect, which we will see later. And if electron density is withdrawn, means taken away from a conjugated carbon chain by an element, then the inductive effect is called minus inductive effect or minus I effect. So fluorine shows a higher minus I effect due to its high electronegativity. And in the case of fluorine connected to a conjugated system, it is found that its plus M or plus R effect is less than minus I effect, so that the delta negative here will be very, very small in magnitude. Now when we connect a chlorine to a conjugated system, the lone pair orbital of chlorine is a 3p orbital. Now a 3p orbital is larger in size than a 2p orbital. Carbon provides a 2p orbital while fluorine provides a 3p orbital. Now when the orbital becomes larger in size, naturally we can say the electron probability density or electron density will be less, because electron density means probability divided by the volume of the orbital. Just like density being mass by volume, electron density will be equal to or will be the same as the number of probability points per volume of the orbital. So 3p orbital will be having a lower electron density, so that when this carbon with its orbital or vacant orbital overlaps with the filled 3p orbital, the overlapped region of carbon and 3p orbital of chlorine will be having a lower electron density. So the overlapped region of carbon 1 and the 3p orbital of chlorine will be having a lower electron density, so that by Mesomeric mechanism the electron density transferred to the conjugated system will be less. So when we consider the resonance hybrid, delta negative will be here of lower magnitude, because chlorine is providing a large orbital, a 3p orbital having lower electron density, and hence the overlapped region of carbon 1 orbital and 3p orbital of chlorine will be having a lower electron density. So mesomeric effect of chlorine, as in the case of fluorine, will be less than expected. Now when we come to the other halogens, bromine will provide a 4p orbital and iodine a 5p orbital, which are still higher in size, so that the electron density of these orbitals gradually decreases and the overlapped region will be having lesser and lesser electron density, so that in the case of bromine and iodine the electron density transferred to the conjugated system will be lesser and lesser. So halogens are particular in that they supply a lower electron density to the conjugated system. In the case of fluorine, electronegativity is the factor, whereas in the case of other halogens, the size of the p orbital which overlaps the orbital of carbon is the factor. As size increases, electron density increases, and the overlapped region will be having a lesser electron density, so that a lesser electron density is transferred to the conjugated system. Now consider two atoms A and B connected by a triple bond. A triple bond B. Now in a triple bond, one bond will be a sigma bond and the other two will be pi bonds. Now an approximate picture of the situation is shown here. The sigma bond formed by face-to-face overlap and the pi bond formed by lateral overlap. And it is evident from the figure that the sigma electron pairs are more close to the nucleus of A and B, whereas pi electron pairs are a little away from the nuclei. So both A and B get a lower hold over the pi electrons because they are situated a little away from the nuclei. So in effect, A and B feel the deficiency of electrons, especially pi electrons. So A and B being electron deficient in the sense that pi electrons are a little away from the nuclei of both A and B, they will be having a tendency to acquire more electrons when they are connected to other atoms by single bonds. So the bonding pairs will be more shifted towards A or B when they are connected to other atoms using bonds, so that the electronegativity of A and B increases. So in a triple bond, the electronegativity of atoms increases because the pi electrons are overlapping, pi orbitals are overlapping away from the internuclear region, and the pi electrons are slightly moved away from the nuclei of both atoms, forming the pi bond. So electronegativity, we find it's not a constant quantity. It depends upon the type of bond formed by the atoms. In fact, a triple bonded nitrogen is as electronegative as fluorine. Now consider this group. This group is called a cyano group. Consider a cyano group attached to a conjugated system. Due to high electronegativity of nitrogen, the pi bond will be shifting in the direction of nitrogen, means the pi bond ionizes and the orbital of nitrogen gets a pair of electrons and hence a negative charge. So the triple bond becomes a double bond. Now simultaneously, this pi electron pair will be shifting in this direction, establishing a bond between these two carbons, will get a positive charge. This pi electron pair moves in this direction, neutralizes the charge, and the charge is obtained over the last carbon, and here that is carbon 4. Now the reverse movement can also occur, and this is because of resonance. So forward and backward movements occur continuously. Now the resonance hybrid will have a net charge delta positive, and delta is a fraction over carbon 4, and on nitrogen we have a delta negative charge. So by this mechanism we can say electron density is taken away from the conjugated system, because the conjugated system is now possessing partial positive charge in the resonance hybrid. Anyway, movement of electrons will stabilize the system, of course, but due to mesomeric effect, the group gets a higher electron density. The nitrogen atom in the cyano group gets a higher electron density. Now this type of withdrawal of electron density from a conjugated system by an attached group is called minus mesomeric or minus resonance effect. Now other examples of groups showing minus M effect or minus R effect. Now one example is that of nitro group, which is NO2, and this nitro group has a positive charge over nitrogen, negative charge over oxygen, and this positive charge is alternate to this pi bond, so positive charge we say is conjugated, and again the pi bond here is alternate to this pi bond, so pi bond is also conjugated with the system, so extended conjugation we say. Now bond shift will occur simultaneously like this, and this n double bond polarizes or ionizes in the direction of oxygen, means the pi bond breaks and the oxygen carries an orbital with a pair of electrons, so it gets a negative charge. Now during this shift, a negative charge is obtained by oxygen and another positive charge remains over the nitrogen atom. So nitrogen is now left with the two positive charges, but shift of this pi electron here will neutralize one of the positive charge. So nitrogen carries a positive charge in the second structure, in the second canonical form, and the carbon end carries a positive charge. So in the resonance hybrid, nitrogen will possess the same positive charge, because in both these canonical structures nitrogen possesses +1 charge. So we should write a plus charge here. But oxygen here, this oxygen does not carry any charge, but here it is having a negative charge. And since the contribution of the canonical structure will be less due to its charge, we can say that a delta negative charge will be present over the oxygen atom. And delta means a partial charge. It can be any fraction. It does not specify a particular fraction. And this oxygen atom here carries a full negative charge. This oxygen carries a full negative charge. So in the resonance hybrid also, this oxygen carries a full negative charge. So electron density is withdrawn by nitro group from the conjugated carbon system. Now other examples of groups showing -M or -R effect are the carbonyl group, or it is called ketonic group. This is aldehyde group. This is carboxylic acid group, and this is sulfonic acid group. All these groups have double bonds which are conjugated with the conjugated system, and they show -M effect or electron withdrawing effect. Now that is all. Thank you.